Hello and welcome to another reactions video. This video will cover another alkene addition reaction, and in this case the ozonolysis of alkenes will be studied. So the overall transformation for ozonolysis happens in two parts. This is the first part, where the alkene is transformed into this oxygen-bearing intermediate by the use of ozone, as well as C2Cl2, and a very low temperature in order to create this process. Now the second step has two possible reagents to be added to end up with two different products. So you can add CH32S in order to get ketones and aldehydes if there are hydrogens related to the initial molecule. So if one of these R groups is a hydrogen, then this is going to be relevant. So the CH32S will cause that side to become an aldehyde, but you could also add, instead of this CH32S, you could add H2O as well as H2O2 in order to create carboxylic acids as well as the same ketone as mentioned before. So this is the general mechanism for the first part. The electrons from this double bond will attack this oxygen, moving the electrons from this double bond into this oxygen, and then having the free electrons from this negatively charged oxygen attack a carbon in this. Then the next thing that happens is you have this intermediate, and what will happen here is a cyclic motion of electrons, where electrons from this bond will move into this bond, creating a double bond here, and electrons from this bond will move into this oxygen, creating a negatively charged, formal charged oxygen. Now in order to stabilize that, this oxygen will need a positive charge, so it will have its electrons create a double bond here. And then you end up with these two molecules as intermediates. This is just a ketone, and this is a ketone you could imagine with an oxygen attached, where both of them have opposing formal charges for stability. So now the negative formal charged oxygen will attack this carbon, which will allow the electrons from this double bond to move over here and attack this carbon here. And then these electrons from this double bond will move into the positively charged oxygen, creating the intermediate. Now when this intermediate is treated with CH32S, it will, as described before, create a ketone for this side and an aldehyde for this side. And if you do it with H2O2 and H2O, you will end up with carboxylic acids instead of aldehydes, and you'll still end up with the same ketone. So you can imagine the overall transformation for this is that this portion here gets cleaved and replaced with an oxygen on either side. So what happens is this bond gets cut in half and you replace it with an oxygen on each side. So you end up with carbonyl groups on either molecule that ends up from the overall transformation. Thank you for watching.